Before we get started, just a real quick reminder. If you see me write something down, then you got to write it too. Welcome everybody to section 9.2, the converse of the Pythagorean theorem. And yesterday we learned about the Pythagorean theorem. Today we're going to learn about its converse. What's a converse? So here's a statement. It's an if-then statement. If you compete in blue and gold day, then you're a student at SCH. And many of you do compete in blue and gold day and all the races that are on the field. And all of you that compete in blue and gold day go to SCH. However, there's some people here listening to this video who don't compete in blue and gold day. They might compete in blue and blue day, or they might not compete at all, and for whatever reason. So there are plenty of people at SCH who are not necessarily going to be competing in blue and gold day. The converse of this statement is we take the green part and you move it over here. You take this first part, the if, and make it the then part. So you switch them. If the converse of that statement would be if you are a student at SCH, then you compete in blue and gold day. And that's actually not true. There's plenty of people, if you compete in blue and blue day, or if you don't compete at all for whatever reason, then you're a counterexample to show that this converse is actually not always true. So I just wanted to say that just to illustrate what a converse is. A converse of a statement is when you switch the if and then parts. The first comes second and the second one comes first. That's what a converse is. And a converse is not necessarily always true, as we can see here. So often when we make an if-then statement, if we state a theorem, then it's natural to wonder, well, is the converse going to be true also? Because it sometimes isn't, like here in this example. The converse of the Pythagorean theorem. So here's the 9.1, the theorem that we talked about yesterday. If it's a right triangle, then you know that the equation a squared plus b squared is equal to c squared. So it's natural to wonder whether or not the 9.2, the converse, is also true. If you switch it around, then you get if all the lengths on the triangle a squared plus b squared is equal to c squared, then it's a right triangle. And it's you might assume that it is, but we can't always assume that a converse is true, like we see up here. So I had a great I had a great activity in mind for us doing this, to figuring out and establishing, inductively whether or not it is true. Get lots of data and see if the pattern holds. So here are some lengths that a triangle could have. A triangle could be a 3, 4, 5 triangle. The lengths 3, the leg would be 3, the other leg would be 4, and the hypotenuse would be 5. And you can see that all of these triples right here, all of these groups of numbers, each individually satisfy a squared plus b squared equals c squared. So 3 squared plus 4 squared does equal 5 squared. 7 squared plus 24 squared does equal 25 squared. They're very famous groups of numbers called Pythagorean triples. And actually, they're not just distinct to Pythagoras. You can see here's a Babylonian tablet suggesting there's several advanced Pythagorean triples, such as 1,679 squared plus 2,400 squared is equal to 2,929 squared. Pretty cool stuff that it's that universal. And so here you can see the Egyptians even used 3, 4, 5. You can see a picture right here. 3. This is a length of 3, a length of 4, and then a length of 5, and they were called rope stretchers. And the activity that I had planned for us would be to rope stretch also. With these, you can read up on it more if you want, but we're just going to move ahead and take a look here. So the activity would be to have a 3, 4, 5 rope stretching activity, so you could find out and measure that it actually really is a right triangle. Each of these groups of numbers makes a triangle that does happen to be a right triangle, and you can prove it with an argument if you want. So in exercises 1 through 6, use the converse of the Pythagorean theorem. That is, if the numbers satisfy the equation, then it's a right triangle. Use the converse of the Pythagorean theorem to determine whether or not each triangle is a right triangle. So you start off with all 3 numbers, and you wonder whether or not they satisfy the equation. So 8, we're given 8, 15, and 17. So 8 squared plus 15 squared, is that equal to 17 squared? We do the calculations and you figure out that yes, it is. So because it satisfies the equation, then you know, yes, it is a right triangle. The answer, it's going to be a yes or no question. Is it a right triangle? Yes, it is a right triangle, because if it satisfies the numbers, then it's a right triangle. Let's do number 2. So let's see, we've got 50, 120, 130. Does it satisfy the Pythagorean theorem equation? The Pythagorean equation, and we get 50 squared plus 120 squared. Is that equal to 130 squared? You do the calculations, and yeah, it is. So therefore, you can say that it is a right triangle, even though it's not marked. It might look like it a little bit, but there's no markings here to tell us definitely for sure. We rely on the numbers and the Pythagorean equation. So here's how you'd set up number 3. You've got the longest one goes all the way by itself over here. That's got to be the hypotenuse, and the other 2 shorter ones go over here. And then you wonder whether or not the left side is equal to right side. I want you to figure it out. Go ahead and use your calculator, pause the video, come up with a yes or no answer, check it in the back of the packet, and then unpause the video, and we'll do the next one together. Actually, we won't do the next one. I'd like you to do number 4, number 5, number 6. Go ahead and do them all the same way and check them all in the back. Let's do some word problems. Is a triangle with sides measuring 9 feet, 12 feet, and 18 feet a right triangle? Well, you'd set it up like this. The largest one goes all by itself as the hypotenuse, and you'd wonder whether or not 9 squared plus 12 squared is equal to 18 squared. If it does, then it is a right triangle. If it doesn't, it's not. Number 8, this is an architectural application. This is one thing that people do to test whether or not they've got a right angle as they form a triangle. You can see this carpenter right here. This guy looking at the window, he knows this length and he knows this length, and then he can also measure this length. If you don't have a right square or a right triangle to measure, then you can calculate what this would be. A window frame that seems rectangular, notice the word seems, it's not guaranteed that this is a right triangle or a right angle, has a height 408, that's this, at length 306, that's this, and one diagonal that he's measuring right now with a length of 525. Is the window frame really rectangular? Go ahead and explain. Show me the work and go ahead and explain. Number 9. Both quadrilaterals are squares. If it's a square, then you can find, like, this is 15 centimeters, and this is 15, and this is 15, and I didn't write it in, but this is also 15 right here. And so if it's a square, then this area is 25 centimeters, then this has got to be 5 centimeters, 5 centimeters. And we want to find out what y is. That happens to be the hypotenuse of a right triangle, or a triangle that I'm drawing right here. I know, and because it's a square, this is going to be a 90-degree angle. I didn't draw it in, but we know this as a fact to be 90 degrees. So therefore, we can add this 15. We can add this 15 over here plus this 5 to get 20 centimeters. And so therefore, it's got to satisfy the Pythagorean theorem, and so we can use that to find out what y is. Here, we're seeing this circle again. Notice one point is at the origin, and another point is on the circle. The circle is centered around the origin. And it's kind of tricky to find the right triangle in this, but one way to do it would be to draw a horizontal line right here. Another way to do it would honestly be to draw another line right here. But I went from over here because I had the space. So here's the right triangle. And this has a value of -7. I got that from the point. The point is -7 over and y up. So that's why I labeled the triangle -7 and y. Now, you can plug in 7 or -7, it doesn't matter. If you want, but you can use that to find out what y is. And here's the right triangle, number 11. 18 squared plus y squared is equal to 25 squared. So there it is. Go ahead and take a photo of both sides, upload it to Haiku Power School. Good job finishing the video, and I'll see you around.